Okay, so we're going to look at number 20, which I started and the video actually died on me. So we're going to try to start again. Number 20, you've got where you're looking for finding the length of side EA using proportions. Now, that should have a segment symbol over it because we're actually talking about the side itself. If we were just talking about distance or length, then it would not have a symbol over it. So when we're actually talking about the side itself, when referring to that, we would say side EA with the segment symbol. So we're looking at proportions. Proportions are two equal ratios, not the same size, or two equal ratios. So if we're looking at proportions, we're looking at two equal ratios. Now, similarity means that they're the same shape but not necessarily the same size. So when two things are similar, it's kind of like a dilation. A dilation creates similar figures. You're keeping the same aspect ratio, you're keeping the same proportional relationships. It's just like enlarging a photograph. If you enlarge a photograph and you don't keep it proportional, it's going to look weird. You've seen pictures before where you've enlarged a photo or you've shrunk a photo and the person looks a little bit odd because you haven't kept the proportions the same. You can always tell when a photograph has not been proportionally changed. So when we do similarity, we're looking for the objects to actually still be the same shape. So what I have is I have these two triangles here, and I'm going to put them in color for you. So we've got the smaller triangle right here. This is triangle EDC. And that is actually the same shape as the larger triangle, which is EBA. So if you can see here what I'm doing, I'm showing you the two triangles that we're going to be focusing on. Those two triangles are the exact same shape, they're just not the same size. So the question is, what is the length of side EA? That's this one right here. So I'm going to kind of highlight this one in purple. This is the one that we're looking at right here. I want to know what's the length of this one. Well, to establish that, I have to use some kind of proportions. When you have similar figures, they are proportional to each other, which means they have the same relationship. So let's look at the values that we do have with the two triangles. On the red triangle, I've got 10, and on the big triangle, I have 15. So those are my ratios. I have 10 to 15. That's got to give me the same ratio as these sides over here. And we're talking about 12 is the small triangle, right? And then we're talking about the entire side, right? We're going red to green over equals red to green. So green would be X. I apologize, my daughter is being immature and screaming. So what I'm going to do now is I know these have to be equal ratios. 10 to 15 has to give me the same proportion, the same ratio as 12 to X, and I'm going to call this X instead of question mark. So we solve proportions, we cross multiply. So I've got 10x, equals, and then I've got 15 times 12. So 15 times 12 gives me 180. So I've got 10x equals 180. So I'm going to divide both sides by 10. So that means X has to equal 18. Now, when I'm looking at this, look at my ratios. 10 to 15, let's look at these ratios individually. 10 to 15 actually gives me what when I reduce it? 2/3, or a 2 to 3 ratio, right? So that means 12 to 18 should give me this magic ratio here. So if I do 12 over 18, because I just found out X was 18, I do in fact get 2/3. So I know I've done it right. And again, that's using proportions to find similar figures. Now let's look at number 21. Number 21 is talking about free throws. It says Carter made 12 out of his first 20. So he's going to make 12 out of his first 20. At this rate, if he shoots 450, how many will he miss? Well, let's look at the question. What is the original? The original is makes over total shots, right? So we've got makes over total shots. So what I want to do is create another ratio that's the same thing, makes over total shots. So the question is, if he makes 12 out of 20, how many will he miss? Now that's key. It's how many he will miss. Sorry. It's how many will he miss. Well, let's find out how many he will make first. Makes over shots equals, so if he shoots 450, remember the total goes on the bottom, isn't that what we have? Makes over total. How many is he going to make out of 450? So what we'll do is we'll cross multiply, and we've got 20x, and I'm going to use my calculator because I can do that. And then you got 450 times 12, which is 5,400. I divide both sides by 20 because I want to solve for x. So I'm going to come up here. So x equals 5,400 divided by 20, which is 270. Now, 270 tells me how many makes he has. So if he shoots 450 shots, he's going to make 270. So how many is he going to miss? Because the question is asking you how many he's going to miss. So what I'm going to do is I'm going to take the 450 shots that he's going to take, and I'm going to subtract the 270 that he's going to make, and that will tell me how many he's going to miss. So he's actually going to miss 180 shots. The key on this is that you don't get mixed up, because a lot of people look at this and we're assuming it's asking how many he's going to make. It's asking how many he's going to miss. So makes over total equals makes over total equals makes over total. Makes over total equals makes over total. And once you find out how many he's going to make, then you subtract to find out how many he's going to miss.